Welcome to the what I'm calling Project Rubber Ducky. That's right, it's the sounding board, episode 2. And today we are going to be talking about Lambda functions, specifically serverless functions, and how they fit into the serverless environment. Where did this start? What's this about? Is probably what you're asking straight away. The sounding board is ultimately a place where people can send questions in, they can ask for opinions, or they can ask how to achieve something with AWS. Very much the sounding board, the rubber ducky debugging place. So make sure you've got your rubber ducky handy because you're going to need it to ask the questions. We asked the community when we first started this, how do we, what do you want to hear about? And the first thing that people said was they want to hear about how to go serverless, how to serverless. And so we started last week with how to do serverless containers. And this week we're talking about serverless functions, Lambda functions, and interconnecting parts. How to get involved. If you want to get involved, ask a question, maybe first of all, we've got the comments section down below, but also if you want to suggest a topic to talk about in another week, don't forget to make sure you scan the QR code just up here, because that's going to send you to a form and you can ask for certain topics as well. Cool. Let's get started, shall we? So the first question to ask is, what is a serverless function? And so ultimately in the AWS environment, it's we call it a Lambda function. It's a piece of code that's designed to run without a without a server, without all that operational overhead, and without all that tin box server that we're so used to. In the past, we run our PHP server or our web server on a EC2 instance or on a virtual machine, and then we have to patch the web server. We have to patch the operating system. We have to protect it with firewalls and network infrastructure, and it gets quite laborious. A Lambda function, a serverless function, is designed to remove that effort from the setup. You just want to code, right? At the end of the day, if you're a developer or a builder, you just want to code and do something cool. You don't want to worry about all that outside stuff that might spoil your fun. How does AWS Lambda work? It's a great question as well. And from that perspective, Lambda is designed to take the code and under the code. And in the background, AWS run all that infrastructure for you on their mega hypervisors called Nitro to basically run that code in a tiny little container, just like we spoke about last week, but of its own accord. You give it the code, you give it a thing, an action, an event, and in return, it responds with a response. And that response is generally the output that you expected from the Lambda function, whether you were translating data from A to B, whether you were processing an image instead. So say you wanted to scale an image from full size right down to just a thumbnail. You can do that with a Lambda function as well. And so ultimately, how does it work? It sits there in its own tiny little virtual container sort of thing, where it accepts your data and spits out the result that you want. It connects to many, many services as well. It can connect to everything from an API gateway, so you can turn it into an API. If you've got a data source in your environment, you could use Lambda to query that data source and return that back using API gateway and connecting that with other things in your environment. What an API gateway is a mechanism to turn your data into an easily accessible application programmable interface. Supported languages, there's many of them. There's a lot of popular ones in there, such as Python and Node or JavaScript, as well as Go, Java, and I'm sure we'll get into it very shortly, but also .NET's in there as well. So when we look at the demo very shortly, we will actually look at what runtimes are available in there. And if you can spot your favorite language, great. Let's get started programming. As far as the cost of Lambda is concerned, this is probably one of the coolest things for AWS Lambda, and that is it's one of the cheapest compute services to run. AWS give you a very generous free tier of approximately 1 million requests per month for free before you even start paying for the requests within Lambda. And after that, it's a very economical language and service to use compared to running an EC2 instance all the time. Ultimately, with Lambda, you pay for each request, and that's what makes it so appealing. If you've got a web stack or app that you've configured, you can either pay for it to sit on an EC2 instance where you could be paying anything from $100 to thousands of dollars per month, or you could just pay for the requests. And there are requests that go through only, so request by request, user by user. That means that you're only going to be paying a lot less, not a standing charge, just paying for when the Lambda runs. Things that you can do with Lambda functions, such as events. I mentioned that you can connect things or events or triggers into Lambda. I mentioned an API gateway to start with earlier. Yes, an API gateway can request information from a Lambda function and it can return it back to the API gateway. You can also have it so it can connect to other sources, such as data storage sources like S3. When you upload an object to S3, you could trigger an action on that particular S3 object, such as I mentioned earlier, a picture that needs scaling down to a thumbnail. You upload the picture, and then a Lambda function will know to scale that down to a thumbnail and then return that to wherever you want to. You could put it into another S3 bucket, or you could email it back to the user. Who knows? Lots of creative ways. You can also trigger on DynamoDB as well, and this is something we talk about next week in our serverless databases, but you can also trigger based upon data actions too. There's many, many triggers, and this is just 3 of hundreds of different use cases that you could do with Lambda. But if you've got an event that can be triggered inside of AWS, you can probably send it to Lambda. In terms of scaling and concurrency, another powerful feature of Lambda is that because it's serverless and it's hosted in AWS's infrastructure, it scales very easily and powerfully. So if you've got a web application and you go from having one person querying it per hour to 100 people per hour, it will easily launch a Lambda function or a Lambda instance for each one of those users with no problem. And you'll not notice any difference in slowdown or anything like that, like you would with a shared web server. There are strategies to optimize performance of your Lambda function. For example, when you launch a Lambda function, you can give it a set of memory, and that also increases the speed of the Lambda function as well. These are things that we investigate very shortly when we go through the demo, but that can also then make your Lambda functions faster and scale faster too. A lot of people get concerned about security when it comes to serverless technology. They think it's in the public internet, so therefore it's not secure. Rest assured, there are ways of securing your Lambda functions. You could host it inside of a virtual private cloud or a VPC. You could also assign certain permissions to the Lambda function as well. In fact, when you launch a Lambda function, it's got the bare minimum permissions that it needs just to run. You then have to add permissions to it so it can access things like S3 to scale that thumbnail down, or access DynamoDB to access the data it needs to process. So security best practices are inherently in Lambda, and they are followed as you build as well. There's also access control mechanisms available too. So if you do put it in your VPC, which may or may not have access to the internet, you can also apply things like security groups to a Lambda function as well. And then before we dive into the demo, let's talk about observability. What do I mean by observability? I mean monitoring, logging. When you run your Lambda function, what you'll find is you're going to want to see what it did. All of the output from the Lambda function is automatically logged to AWS CloudWatch, and that integration is by default. If you want to increase the visibility, you can use logging agents inside of a Lambda function. So if you're used to Python with the logging module, for example, that will then output to CloudWatch as well. And then that way you can define whether you want debug level, error level, or critical level only as well. You can also then set up metrics and alarms for those metrics based upon the Lambda function. So there's some really basic metrics that come out of the Lambda function to start with, the CPU usage, the time it took to run, and that time to run is very important because that's how you'll build. You can then also, with the log files that are sent to CloudWatch, monitor for certain key phrases using a filter, which would then you can set an alarm based upon that filter as well. So if you're looking for the word error or you're got exception checking in your function, you could then have that exception tracked as well, and then it would alert as an error. There is also tracking of graceful shutdown versus not graceful shutdown in terms of errors and not and a clean run. That's also a default metric as well. To debug a Lambda function, you would definitely use all those features just mentioned. You would certainly be using your CloudWatch logs. You would also then be using your alarms and metrics. But also, if you wanted to have closer monitoring on Lambda, say, for example, you really need that inside app tracing, you could also utilize things like AWS X-Ray. As part of your Lambda function. And then that way that you get the metrics and the visual traces out of that Lambda function to understand what actually happened in your Lambda function as well. Okay, I've been talking for about 10 minutes about what Lambda is. I've probably put you all to sleep by now. So let's do something fun. So let's open up my my AWS console. So if I add that there, it's just gone straight over my face. That's nice of it, isn't it? Let's go for something more friendly, shall we? Something a little bit like that. Cool. You don't have to see me if you don't want to, or there we go. I'm back on the screen now. But I'm not important. What is important here is the AWS console. I'm just going to zoom in here so you can see this. So I'm in the home screen of my AWS account, and we're going to go and create a hello world function. Lambda's really cool for getting started as well in the console. There's lots of resources as soon as you log into a new account to help you get started here. So if we click on Lambda, which I just did, it looks a little bit like this, the icon, or you can search it in the search bar as well. So it looks a little bit like that. But if we go straight into Lambda, and the first thing you're presented with as a brand new AWS account is the Get Started page, which is great. Already, it's offering you ways of testing. AWS love that playground. So you'll find a playground in a lot of features and a lot of services to help you get started, like Bedrock, PartyRock, Lambda, where you can just go and try. So here, what it's showing you is the code for a Node.js hello world, or even a Python one. Ruby is a common runtime as well, and as I mentioned, Java and .NET. You can also use custom runtimes as well. And this is interesting because a custom runtime is dealt with by using what's called a Lambda layer. Ultimately, just think about it as like installing your own software into the function before it runs. We're not going to do that today. But certainly something that's worth looking at if you are not using one of the 5 core runtimes just here. So we're going to go and create our function. Wish me luck. This is the live demo as always, and we can often see this being a tripping hazard. So we're going to author something from scratch. I write Python badly, but I write it. But if you're following along at home, you can also either use Python or whatever your favorite language is. So it's asking us for a name, and we're just going to call this the rubber ducky hello world function. The name just has to be unique in your account, unlike S3, which has to be unique worldwide. So just give it a good name, something that's useful. And then we're going to pick our runtime. Now, I mentioned runtimes. There's many, many of them. So, for example, we've got .NET, Java, Node, Python 3.12. You've then got slightly older runtimes available as well. And then you can also use Amazon Linux 2023 or Amazon Linux 2 for any of the other custom runtimes as well. Yes, even C++ is in there, which surprises me. Let's go and do a Python function. And then I'm just going to leave the rest of the settings as their defaults for now. I'm just going to click on create. When you click on create function, it's in the background. It's basically creating a function and the infrastructure for that function as well. And it might include a default security group or a level of settings that you need for this function. And there you go, it's loaded. We've already got a big green banner that says, congratulations, successful creation of Rubber Ducky Hello World function. I'm sure my Rubber Ducky is very happy about that. In the meantime, if we scroll down, we've got 6 tabs and we've got our code, which is great. So it's already created as a hello world function by default, just to get you started. But what you've got is you've got the code tab here, so you can then continue to modify your code as you need to. We've got a test panel, so you can start to actually test your function using custom parameters. We then have the monitoring tab as well. Now, I mentioned this earlier that you get metrics out of Lambda. This is what this is all about. So you've got the number of invocations available, the duration, the error count and success rate. There's that thing I mentioned earlier, as well as a couple of other really useful metrics as you grow your Lambda function. You can also, from this same tab, go to CloudWatch logs, which we'll do a little bit later, to get an idea about what information gets sent to logs. And you can also then interface with X-Ray or other features to help you develop and grow. Development tools are quite powerful within AWS. And as you can see, we've got an error because we've not run this function yet. So therefore, we don't have a log file. So we'll come back to this very shortly. Under configuration, this is where it gets more powerful. As I mentioned earlier, you can change the memory allocation just here. So I'm going to go with 128 megabytes, which is the default. As I said, Lambda functions are small. They don't need to be powerful. They just need to be have enough memory to be able to run your code at speed. If you find it's not running fast enough, this is where you'd increase that setting. Triggers. As I mentioned earlier, again, you could have a trigger from S3 or any other service in AWS. And then we've got our permissions as well. So at the moment, what you'll see here is that by default, the function has permissions to post CloudWatch logs, and that's about it. You can also go and add extra permissions here if you need to, and you can also then do resource-based policy statements as well. There's a lot of other features here in configuration, which we're not going to be talking about today, but I'll just show you this one, the VPC configuration. So at the moment, I don't have a VPC configuration, so my function is going to be running in Amazon's default VPC that we can't see. It's just going to run. And it will have access to the send things back to the internet, but it won't. Nothing will have a direct internet access to it. But we have no control over that either. But as a default to test, perfect. And then the 5th tab, aliases. You can create versions or tags on your Lambda functions. We call it an alias. So this is where you create that alias. So say you've got 10 versions and you want to have a dev version and a production version, whichever the current one of dev and prod is, you'd set that alias up. And then lastly, versions, different versions of the function, historical versions. So that's a quick crash course in the Lambda console. Let's just see what we've got in code now. So at the moment, it's got a Lambda function for us that it's written in Python. It seems to be importing the JSON module. And then we've got this Lambda handler. The Lambda handler is really important. You can't delete this. The Lambda handler is what defines where your code starts. As a Python developer, there are other ways of doing that when you're not in Lambda. In this case, for your code to start, the starting point is always the Lambda handler. So what we've got here is a status code returns as a 200 code. Now, if you know your HTTP protocol, you'll know that a 200 is a success code. And then we have a JSON string here that is dumping as hello from Lambda. Let's just give it a test. So I'm going to push this test button here and see what happens. And straight away, it runs as fast as possible, and the response comes back as hello from Lambda. Now, that's not a lot of fun, really, is it? So what we're going to do is we're going to modify that now, and we're going to change it to say hello, Alan, instead. Now, when you modify code in Lambda, you need to also deploy the code as a version. I mentioned that earlier. You've got different versions. You need to deploy it, because if I press test now, you'll still see it still says hello from Lambda. So we need to make sure that we deploy this. So it deploys, and you'll see the blue bar then goes to green, successfully deployed. So we then test the function again, and now we get hello, Alan. Now, within our Lambda function, you're not too constrained. You can still use things like functions within your code as well. So I could go back here and say define function 101, and then I can go print this came from my function. I know this is legendary, right? This is legendary coding live. And then we can get rid of this comment that says to do implement, and we can go output is equal to function 101, and then we can print the output. Now, when you print something or do console log in Node within Lambda, it's not going to go to a screen, because this is a headless environment. It has no computer, it has a computer screen, keyboard, mouse, that sort of stuff. So where's it going to go to? Anything that is destined for the standard output in code will go to CloudWatch logs, and that's the fun bit here. So I'm going to run this again. So we've got undeployed changes. So we're going to go deploy. And then I'm going to go, and once that's updated, I'm going to test it. And what we've got here is the response. Hello, Alan, status code 200. And then we've got this log file here, which was in the last one as well, but not really useful till now. You'll see it says this came from my function, and then none. So that non error must be coming from maybe here. Who knows? But ultimately, we have a log file. So let's go back to our metrics now. Now that we've tested and played, you've seen how we modify and edit a Lambda function, and we play with the code, and you can see it's very much normal. So if we go, and I know what I've done wrong there, by the way. There you go. I can hear you all screaming at the screen that I didn't return anything from that function. See, live demos. And we'll just test that again. And there you go. So there's the to function. So we move on to the log file then, because this is the function log for this execution. So what I need to do now is go into monitor. And you can see we've now got invocations. So I'm just going to go and change the stats here so I can just see the last 15 minutes. So it makes more sense to me. And as you can see, it does average-based metric. So it's detected 2 invocations so far. There's about a 5-minute delay on certain CloudWatch metrics. So what you'll find is that all your newer metrics will appear very shortly. We just refresh this again. It should come up very soon. Invocations 2, but then we've also got this duration panel here as well. And you can see that it's taking it's taking anything between 2 and 12 milliseconds to run. And then we've got the error count and success. So we've got all successes and no errors. And then the rest of the metrics are just showing that concurrent executions is 1, because we've only ever one at a time at the moment. So let's go into a little bit further down where we had the error earlier. Oh, and we've now got CloudWatch logs for invocations. If we click on one of these, let's click on the most recent invocation, which is just here, 1923. Our local time here in Brisbane is 7:25 p.m. Good morning or good evening, wherever you are in the world. So we've just clicked on the log file, and you can see straight away in CloudWatch, we've got all this information that appears. We've got whatever came out of our application, plus we have request IDs, which you would use maybe for support reasons or with CloudTrail. But also at the report request, you would then have how long it took as well. So the total build duration here was 13 milliseconds, which is great. That means you can start to also track how much this is going to cost you, especially if you run this at scale. And when we talk scale, we talk mega scale. One of the other cool things you can do with this, because it goes to CloudWatch logs, is you can then use all the CloudWatch log features for this. As I mentioned, you could be filtering on certain terms like error, or you could export it. You could leave it live logging using the tail, and you can search and filter events just when you're looking for specific events as well, just to browse. Okay, let's go back to our function. One of the other things that I mentioned earlier was integrating with different events or different triggers, especially an API gateway. Now, what I want to try and do is put together an API gateway to then respond to this. Now, this could fail miserably, but let's give it a whack. So if we go into API gateway here, and then we choose HTTP API, we're going to give it a name. So in this case, and this name is Rubber Ducky API Gateway. Next. Now, do we have to add an integration? We do. There we go, Lambda. And then we choose our Lambda function. Cool. We are then going to press next, and we need to give it a route. A route is just ultimately how you acknowledge that particular API path. So we'll call this hello, and we'll send it to Rubber Ducky. And then we'll just stick with our defaults and create. So at that point, fairly easy just to configure. Once you've got your Lambda function, you start your API gateway, it shows you your Lambda functions. This is so much easier than it used to be, by the way. Like years ago when I started, years ago, I had pages and pages and pages of settings. Now it is, that was 4 or 5 clicks by the looks of things. So just like a Lambda function, when you make an API gateway, you need to deploy it. So we are going to deploy it, and we're going to give it a stage. We can use the defaults. It's not letting us use the default. That's interesting. Is that because we don't need to? There you go. I wonder if it is already deployed, and that's why it won't let me do it. There we go. Yes, it was already there. So what we have here is our invoke URL. Copy a link address. And then we're just going to copy and paste that. And there you go. So what you'll see there is in just a couple of actions, we have created a Lambda function. We've then created an API gateway, and now we can interface with that Lambda function from the outside world. Now imagine if that was something more like a data set that we were allowing customers to access, or maybe even a web app that you wanted to expose to the world. That's how you would do it with an API gateway. So that was in the console, but sometimes people, developers, builders don't want to be doing things in the console. As you've just noticed, I've done a lot of actions here, but you forget what you did. And so that means you've then got to remember what you did, especially if something happens to your application. You've got to rebuild it, or you want to build it in another region. You want to replicate it. And sometimes you don't remember all the actions you took. So therefore, it's better to do it in a code manner, doing it as infrastructure as code. Now, I'm not going to go into the depths of infrastructure as code, but what I am going to introduce you to is a product called AWS SAM. SAM is an open source developer tool that makes it easy for you to deploy things like Lambda functions, API gateways, and serverless resources. It's very much treating serverless resources like Lego bricks. It can then interface with other applications as well within the AWS console that help you build further. So we're going to go through and do a basic hello world API gateway and Lambda function using AWS SAM, and then you'll see why it's so powerful. So I just need to change my screen. So we're going to stop the screen share. Wish me luck. And we are going to go into VS Code. I don't know what your favorite IDE is or what your favorite coder is. But one of the things that I like is Visual Studio Code because of how powerful it can be. Cool. Now that's open. I'm going to present that to the world. He says. It was, oh, there it is. Couldn't see the wood for the trees. And then we're going to add that. Cool. All right. So we have a blank VS Code in the screen. So we're going to need a terminal window. Now, if you want to follow along, you might need the AWS SAM CLI. That's where you can find it. Don't panic if you can't follow along live. This is recorded. You'll be able to see this through either LinkedIn or YouTube after the event to then follow this along later as well. But if you have got SAM installed already, or you have managed to get it installed in the meantime, then feel free to follow along. Okay, so one of the things that I need to do is this. Don't worry about those keys. They are temporary. They won't work tomorrow or even after this event. But in the meantime, what we're going to do is create ourselves a SAM function, a Lambda function, and an API gateway using SAM. SAM's really cool. It helps you get started. All we need to do is type in the word SAM and then init. And it's already going to be asking you the common sense questions on how you want to get started. We want to do a hello world just to help us understand and get started and learn. So we're going to go quick start template. And then we're going to use the hello world example. Note all the other examples it's got in there as well. Very powerful to be using these examples and learning from, especially like a machine learning example, the serverless API example, or even a multi-step workflow. So I'm just going to pick my hello world example for now to keep things simple. And I've just noticed you can't see the bottom there. So what I'm going to do is just get rid of my name. Nobody needs my name on the screen now. And also let's get rid of that SAM banner as well. There you go. You can see now. It's going to ask us some common sense defaults. Do you want to use Python and zip? Well, I do. But I'm going to say no for now so you can see what else it offers you. As you can see, it's offering us other runtimes like .NET, Go, Java, Node, Python, Rust, Ruby, all these runtimes you saw in the console earlier during the demo. I'm going to pick my favorite, Python 3.11. Why not 3.12? I don't know. I like 3.11. And then what sort of package would you like to use? Just by default, we're just going to use the zip. By zip, it means it uploads the code in a zip file into Lambda, whereas image would create a container image and then run that from Lambda instead. Today, we're just covering the zip format. And then it's going to ask us other common sense questions. Do you want to enable X-ray? I mentioned X-ray earlier as a form of monitoring for the Lambda function. Again, SAM supports the implementation of X-ray into your function. Today, we're not going to cover that. But all of these options are now coming together in a single package just through a few prompts. Do I want to do CloudWatch Insights. If it was a more complicated application, yes, I would. But today, I'm just going to go with the default of no. And lastly, structured login. I mentioned logging earlier today as well. Do we want to enable that? I'm going to say no just to keep this simple. But again, lots of options. Now we need to give it a name. This is my rubber ducky SAM app. You can call it whatever you want. But this is important when it comes to deploying this later. Now, what you'll notice is it gives you some best practice next steps. So you can then go into the folder and make a pipeline. What's a pipeline? More on that very shortly. Or you can test the application or run it. As you can see here, it created a folder called Rubber Ducky SAM App, and we open that, and there's actually a few files in here. And you'll notice it's got a template and a folder called Hello World. They're the two that I'm going to call out straight away. So if we click on template, what you're going to see is a YAML file, which, I know it's a lovely word, isn't it? YAML. It sounds nice, but it can be terrible to deal with. Just make sure you get your tabs right. But YAML, yes. YAML is a line-by-line configuration of what I just showed you in the console. Everything that was in that console that you saw earlier, it can be put into this file to then configure. The power of that is you can make as many of these in as many regions as you want to help make it more scalable, more performant, or to help with disaster recovery. You don't have to remember all those different clicks that you went through to build your Lambda function and your API gateway. What you'll also notice is something really cool. And this is the reason I wanted to show you SAM. You have your function, hello world function, has a folder under the code URI, which is here, as I mentioned earlier. And then it has events. Now, I mentioned earlier, Lambda functions can be triggered. They can be triggered by API gateways, 3 buckets, DynamoDB, or whatever event that might be out there. You can call this in the space of a couple of lines instead of having to build up an API gateway or whatever that event might be. So in the space of 1, 2, 3, 4, 5, remember all those settings that we picked in the API gateway? You just attach it to the function rather than making a separate resource. This is just a configuration file for your architecture. And then at the end of the screen, there's some outputs. These are important when it comes to deploying the stack, and I'll show you what that looks like in a minute. If we look at the Hello World folder, which is the folder for our code, you'll see we've got an app.py. Just open that, and you can see it's got some sample code in it. It's got some comments in it as well, just to help you understand what you can do in here. But ultimately, it's got a lot of the same that we had earlier, and that is this return statement here of hello world. So what we're going to do now is we're going to try and deploy this into our AWS account. So I'm going to go with that build, and it is going to try and build the function for me. So what it's doing now is just taken that code, quickly tested it, and then put it into another set of configurations ready to upload. Then we're going to go SAM deploy. And as you can see, it's now doing things. What it's doing is it's starting to create a set of actions that it needs to deploy into AWS using CloudFormation. That's an automated way of installing things in AWS without clicking everywhere. You'll see that even though we only had one resource, that one resource was our function, we are going to be implementing the Lambda permission resource an IAM role, the function itself, the API gateway, and then the configurations around the API gateway. So that's actually 1, 2, 3, 4, 5, 6 resources that are deployed for us based upon our basic configuration. So I want to say yes here to deploying that. And what we'll see is it will start to do things in the background. And this is where I'm praying to whatever demo deity is out there tonight that this goes right. In the meantime, whilst this deploys, I'll show you what that looks like from the perspective of the AWS console. If we go back to our AWS console, and I bring that to screen, I'm going to go into CloudFormation so you can see what's happening here. What you'll see is Rubber Ducky SAM app has launched in such a way that you can see all the resources that were mentioned there. So these resources match what we had in our SAM change set. Now, I mentioned outputs as well earlier. Now, those outputs are important, and they will end up here. And what you'll see is it actually outputs the URL for our API gateway. Now, if I've done this correctly, I should be able to click on that, and it says hello world. So what we've done is, in the space of a couple of actions and a couple of lines of code, we've created an API gateway, a Lambda function, and all the relative infrastructure to make our app present on the internet. That's SAM in a nutshell. Let's have a quick look at what that looks like in the console for our Lambda function. So you can see here we've got Rubber Ducky, SAM app, hello world function. This is the one that just got deployed 1 minute ago. And you'll see it's no different to our other Lambda function. It's got a bit more detail in the code because that's what it generated, and a few other folders attached to it that are best practice folders for the way it suggests your code. But you'll see it's got all this configuration already done for us, general configurations done, permission sets for CloudWatch logs. And you'll notice it's also got this trigger here attached to it. That trigger is the API gateway that we created earlier. So again, you'll see we've got our resources, hello, Git. It's got an integration request going to Lambda, and then it's made the stage for us as well, and it's already deployed it. And then I've got our URL that I mentioned earlier to then allow us to execute that API gateway. So ultimately, that is Lambda, that's a serverless function, and that is an API gateway. That's how to get started with a serverless function. If you've got any questions, please feel free to throw them in the comments or send me an email, whatever it's called these days, through LinkedIn. You can get to my LinkedIn through just here. Let's make sure you can see that before I start doing anything useful. There you go. So just here. You can send me a LinkedIn message if you've got any questions about today, or put it in the comments as well. Please be kind. At the end of the day, this is live. This is a live demo, and the demo deities sometimes aren't in our favor, but today went very well. If you want to get involved as well, either you want to have your problem live on air, come and talk about your questions, then feel free to scan the QR code at the top here. Or if the QR code isn't working for you for some reason, you can also go to that link just here. That will allow you to send me a request for a topic, and we can even discuss it on air if we need to. This week was all about Lambda and serverless functions. Next week, we have a guest presenter who's going to help me talk about serverless databases. So we're going to complete the serverless topic. We had serverless containers, serverless functions, and then next week we've got serverless databases with an absolute legend of the serverless community, Boyan, who is a ambassador and also a community builder as well. So we'll get him involved, ask him some questions. If you've got any questions in advance about serverless databases, please, again, let me know via LinkedIn or via the form just there. I always get my left and my right mixed up. If you've got any feedback, please let me know. Again, LinkedIn. Otherwise, remember, if you've got a problem, have you tried explaining it to Rubber Duck? Good night. Take care.